Okay, so today is lesson 3 on rational expressions, and you know what really happens on these is they just get a little more complicated. Right now, if you can factor it, you should, is the line that keeps coming up over and over and over again. The top of this can factor, the bottom can factor. Once you got both factored, usually something's canceled. So I'm going to pause for a second while you give this one a try. Factor the top, factor the bottom, see if anything cancels. And I'll show you the movie after we do this one. I'm hoping that this one was pretty easy for you. -9 comes out, x plus 2. Or did you by accident only take out regular 9? Okay, if you take out -9, it's going to work better. On the bottom, we have x plus 2. I'm just assuming it's x plus 2 because I'm figuring they're probably going to cancel. But I have to check. So I think it's probably x plus 2 and then x, and then let me think. If I'm going to make a -8, what would I have to put here? -4. And then I check and see if that actually works. First, x squared. Outside and inside makes a total of -2x, and that's what I wanted. And the last we already checked, and that makes -8. Sweet. It's right. That means I cancel the x plus 2's, and my final answer is -9 over x minus 4. Raise your hand if you had that one right. Okay, good. This one, a whole movie. Sorry, you guys recognize that one? Breakfast Club. It's a classic teenage movie. All right, this one is a little. If you can factor it, you should exercise again. Tons of things are going to cancel this time. I'll pause for a second while you give this a try. Okay, top one here. By now, if you can't factor, this should be a warning sign to you because next year factoring is huge. We've been practicing it all year. Maybe you just need to get warmed up again, but you need to know how to factor. If you're going to go on, especially to honors pre-calc, factoring has to be like back of your hand, no big deal. All right, so how am I going to make 3 out of 2 numbers? Well, it's got to be a 3 and a 1. It's the only way to make a 3. But then if I want the outside and the inside to add up to -4, I need all of them to like go together and be negative, and so they're both negative. There we go. All over, 4 comes out, x plus 4. Now that might look like, why did I even factor it? Because I can't cancel anything. But the other side over here, 2x plus 8 can be factored into 2x plus 4, and that's what I've been waiting for, something to cancel. And then the x minus 3 down here can also cancel. So that cancels that. This cancels this. And there's one more thing. Yes. A 2 and the 4. So this 4 could be written as 2 times 2. And then this 2 cancels this 2. And then the final answer is x minus 1 over 2. Raise your hand if you got the same thing. Okay, good. So far they've been pretty easy. Remember that one? That's Wheeler's Day Off, yes. I just saw an article the other day that the house that, I don't know if you remember, they had this awesome car in that movie. And then as part of the thing is they realized, oh my gosh, we put a bunch of miles on the car and we got to try to get the miles off the car. So they tried to drive the car backwards to do that, which doesn't actually work, by the way. Note to self, driving the car backwards does not take miles off of it, off the odometer. But then it ends up shattering through and falling down and all that. Well, the actual house, that house is for sale, and it just sold recently. So somebody owned it and somebody bought the house that was in the movie. So guarantee you a lot of people will be driving by their house going like, yeah, that's the house that was in the movie. All right. This one is adding. Why is that different? Can't cancel that kind. Now you could still cancel within, like if here's something in here on top and bottom, those can still cancel, but you can't cancel things from like here and here. That won't work. So when you're adding, you got to get a common denominator. So it still comes down to, if you can factor it, you should. You should not try to look at this and figure out the common denominator. Don't do that. Factor every place that can be factored, and then look for the common denominator. All right, I'm going to see if you can do this. Factor this if you can, which, by the way, you can't. So then there's really only one place that can be factored. That makes it simple. Do that one place that can be factored. Sorry, hold on, I'm having technical issues here. And move from there to, once you've got it factored, you'll be able to see, I hope, what to multiply this side by so that you will have a common denominator. Then actually add them together. All right? So figure out what to multiply the right side by to get a common denominator, and that'll help a lot if you factor. Can factor, you should. Okay, here's what I meant by factoring this bottom part. If I have 9x plus 14 over, x can come out of those. And what do I have left when I take out the x? X plus 7. And the cool thing is, I already have an x plus 7 over here. So the way you got to think of this is, what's a good denominator? That way you could both have x and an x plus 7. This is the good denominator they should have. So then I just got to figure out what should I put here and here so that x. Because as soon as I slap an x here, I can see that they are the same. The denominators will be the same. So if I times that by x, I need to times the top by x. Then I actually have to put these together. This, of course, I hope you know, makes x squared. And then this is plus the rest of it because it says plus here. So it's x squared plus 9x plus 14 all over. On the denominator, you don't multiply them out. If you can factor it, you should. Just leave it factored. And it'd be really cool if this would factor on the top, but it doesn't. Oh, it does. Okay. Sorry about that. Last hour, I'm glad I didn't use the video from last hour. I thought that the top didn't factor. Hold on. I'm not saying you're wrong. I just kind of looked at it and one of the kids said, "Oh, it doesn't factor," and I went on. So, okay. Anyway, it does factor. So I can take this and break it into, I'm assuming an x plus 7 because there's one on the bottom, but don't ever just assume that. I'm going to check it. The top here can also have, let me think, x plus 2. Let me check and see if that works. Outside and inside makes 2x and 7x makes 9x. Yes, it does factor. Thank you for catching that. And it's good that it factors because then cancel, cancel. X plus 2 over x. How many got that far? Good. Question.
Why couldn't we couldn't cancel x squared? X times x times.
Why can't we cancel x squared? Okay.
Yeah.
There is an x squared on top and there would be an x squared on the bottom, but they're like this. And I'm not saying exactly what they are, but they're like this. You tell me, why can't I cancel
Oh,
those?
we're adding.
Because there's an adding in between them. All right. So we can cancel when they're factored, when they turn into a multiply problem, see? Then this is multiplied by that. They're both part of a multiply problem. Then you can cancel them off. X plus 2 over x. All right, let's see the movie. Recognize that one? Indiana Jones. And a whole bunch of different Indiana Jones movies. All right, this one. You'll need to find a common denominator. Know how I can tell? Not because of factoring. You can always factor or not factor. It doesn't really matter. What matters is that it's add or subtract. Add and subtract, you have to have common denominators. So since this is a subtract, we will need a common denominator. Yes, you should factor wherever you can. Hint, you cannot factor that. So it pretty much leaves it down to one place that can factor. That will help you figure out what the common denominator is. I'll pause for a second while you give this one a try. This is getting hard because the denominators are hard to make into common denominators. But if you factor them, it's not that bad. All right, let's see how you did on this one. I'm hoping you factored the bottom part because the top couldn't be factored. Yeah. X plus, what was this one? 10?
X plus
-5 and -4. Okay, thank you. -5 and x minus 4. And then, why did that even help? Because nothing's canceling. It's true, nothing is canceling. Why did that help you? Now you can make the bases the same. I like the way you said that. Good. So what do we need over here to make it the same as over here? X minus 4 over here. And then that'll be the same on the top. And then what I can do is actually put them together now, because this multiplies out to the exact same thing as this does. So that's the denominator. Don't always just multiply it out, though. A lot of times it's best to just leave it in its factored form until you get the top done. Okay, now on the top, this is where it gets like a little bit complicated. That has to subtract all that. So I'm going to actually multiply this all out, and then everything gets a negative sign. So this is x squared minus 22 minus x squared, and then I'm foiling it out. That's x squared. This was outside and inside makes negative 6x, but it's the opposite of that, so it's plus 6x. And then that would have been positive 8, because it's negative times negative. But there's this, that makes it negative 8. Whew. Then you actually have to put these things together. The x squared and the minus x squared will cancel each other out. Did you notice that? And then the negative 22 and the negative 8 makes negative 30. And the other thing is a 6x. So I'm going to say 6x minus 30 over x minus 5 and x minus 4. And if you left it that way, I'd cry a little bit and mark it wrong. Because why? Because you can factor it. And then when you can factor it, you can cancel stuff. So 6 comes out of the top, and what do we got left? X minus 5 all over x minus 5. Sweet, there's one on the top, one on the bottom. And then x minus 4. And then these cancel this, and then the final answer is 6 on top, x minus 4 on the bottom. That was intense. That is a pretty typical hard level question for tomorrow. So we are going to be taking this little quiz tomorrow. It's going to have questions like that on it. It's going to count in your homework grade. Don't underestimate that and think, oh, it doesn't really count. Homework counts, just doesn't count as much. Yes?
On this problem, when you FOIL,
Yep.
and then why couldn't you just cancel out the x minus 4 then?
Okay. Well, on the top, when I was foiling this stuff out, this had a subtract x minus 4. So you couldn't cancel it right there. I do get why you might have thought you could. But you had something minus that. It had other business to do first before you could cancel it, because it was part of a subtract problem. So really, the moral of the story was we had to get this whole top added together. And that's where I guarantee you, like most of you dropped out right there when it got really complicated. You made a mistake somewhere in there. I could have easily made a mistake somewhere in there. Yes, sir.
So if there's an addition problem, we wouldn't have.
If it was addition, you'd still have to put everything together. You got to add it all together. Once you got it all added together, then you can factor it. That's what we did. We got it all added together, and it all added up to 6x minus 30. All of this mess right here added up to 6x minus 30. And then from there, we could factor it and cancel. So here's the moral of the story. If I have things like this, and I have things down here, can I cancel them yet? No. I can't cancel stuff like this because it's in part of an add problem. Can't cancel those 4s. Okay? But if this was like a 4 and a 4 and a 4, there was a 4 everywhere, then I could put a 4 out front because this factors. I take the 4 out, and I'd have x squared plus x plus 1. And then that, once I factored it, then I could cancel. So basically, you've got to do all your adding and subtracting first. Then you can factor stuff. Once you got it factored, then you can cancel stuff. So add, subtract first. That's why this one, I needed to do all this big mess here because it was a big add, subtract problem because there's a minus right there. All right. Now they got really messy and really intense, but that's as hard as they can possibly get. Anybody know that one? Willy Wonka and the Chocolate Factory. Very good. Let's just jump through a few last movies here just for fun. Well, what's that one? Wizard of Oz. Awesome. What's this one? Princess Bride. I love that movie too.
What's the guy always say in the middle?
I am Monteo. You killed my father. Prepared to die. Yes. And this guy was always making rhymes.
Oh, yeah.
And this guy really got annoyed by that. And so he would be like, stop rhyming and I mean it. And then the other guy was like, anybody got a peanut? I remember that one. So he would always just rhyme with him constantly. It's a good movie. Okay. And that one? Lion King. All right. By the way, on this one, I'm not going to make you do it right now because we're getting close to the end, and I think you could do it anyway. This divide just means you'd flip and multiply. So this would get flipped up and down, and this would turn into a multiply. And of course, if you can factor it, you should, and then a lot of times things cancel them. So this would have a regular factoring festival, because so many things factor. This factors, this factors, this factors, and then this would cancel with something in here, because do you remember x squared minus 1, what it factors to? X plus 1 and x minus 1. And then those would be on the top here. So then you'd have, and then this x plus 1 could cancel with that one. So anyway, this one, again, instead of dividing by all that, you change it to multiplying by reciprocal. Flip it over. Okay. What is the answer? Oh, okay, the movie. On this one, what's this? Oh, my goodness. Oh, that's right. She's dressed up the little E.T. Yeah, he's wearing so much like dress-up clothes, can't even recognize him. Nope, that's E.T., and that's Drew Barrymore a long time ago. Yes? Good question. It is up to you. You really could factor first and then flip it, or flip it and then factor it. It doesn't matter. The good thing that you knew is that you should factor it. How about something like this that's got, like it's got x to the fourth in it? That just means it's got a whole bunch of x's. Let's just try to factor this one. What comes out of everything? This, and this. X squared. Good. I'm glad you noticed. And then x squared plus 9x minus 10. And then that factor's pretty easy. And then this is a divide problem. Divide problems are awesome because they're really just multiply problems. You just got to flip it over and then multiply it. So, and then a lot of things cancel. All right. How about this? What if I had an x squared over next to the fourth? Can stuff cancel? Yeah, because it really means xx over xx. See, I'm factoring out the top and bottom when I do that. These are the factors of x squared. Now that I got that, I can go cancel, 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 and it's 1 over xx, which is 1 over x squared. Yes?
So, when we like get our answer, and let's say it's like x plus 4 times x minus 2 all over x plus 2, and then at
Yep.
like the top, do you want us to leave it in fact?
Good question. It is totally okay to leave this in factored form. If you want to multiply it all the way out, go ahead. But usually nothing good happens from that. What usually happens is if you keep it in factored form, it's better because then maybe later in the problem you have to multiply by 1 over x minus 2. And if you would have multiplied it all out, you wouldn't have noticed that, oh, this can cancel. You know what I mean? So it's better to keep them in factored form. And then you can leave them in factored form too. That's great. So I would have accepted it if you'd have said x squared plus 2x minus 8. But I like it better in factored form. All right, I think that's enough practice. Your homework for tonight's going to take you enough time. It's the night before our test. I never cut out problems. So there's plenty of practice problems there. There's also all the answers. And tomorrow in class, you'll find out if you really know how to do this stuff. It will count, and it counts as just in the homework category. So I think it'll be like the size of 2 or 3 homework assignments put together in one score. Okay, so do your best on it, and I'll tell you more about that tomorrow. Yes? Good question. This is not on the final because this is something we never will have actually fully tested you on. Not going to have to know it for the final. But as far as like why do I need to know this stuff, it is really powerful stuff for next year. Like you really need to know this, whether you go to regular pre-calc or honors pre-calc, either one. You got to know how to factor, you got to know how to cancel, you got to know how to flip and multiply. All these things we're doing, really good for next year. So the only reason we don't make it like fully test it in is that right now you have so little time left we'd have to devote more days to studying this and then making it a big official test, and that would eat up our review time. And we want to have time to review this whole semester. So, okay, that's all I got for you for today.